Hi there. In this video, we are looking at a differential calculus exam level problem. This question was taken from the November 2024 Maths Paper 1 exam. Okay, let's get into it. So starting with 8.1.1, we have been asked to get the derivative of that equation. So let us begin. D by dx of 3x. So we're going to write d by dx, open square bracket, 3x minus 5x squared. So because we have already been told that we are taking the derivative, we can just start with saying equal to and then go straight into writing the answer. So the derivative of 3x is just 3. And minus 5 would be minus 5 times 2x. And then this simplifies to 3 minus 10x. And that's our answer for 8.1.1. Moving on to 8.1.2, we've been asked to get the first derivative if g of x is equal to that. So let's write the equation of g of x. It's 2 over x squared, I think, minus, and it was the square root of, or the cube root of x to the power of 7. Okay, let's first simplify. So 2 over x squared will be very difficult to get the derivative of. So we're going to convert that from being a fraction to just being a normal exponential. So this then becomes negative 2 in our exponent. And same thing, cube roots or anything with a root is difficult to get the derivative of. So again, we apply exponent laws. So this then becomes 7 over 3. Now our equation is in a form that is easier to get the derivative of. So let's proceed and get g prime x. So we now have 2 by 2 and the other 2 is negative. And then here we've got negative 3. And then here we've got 7 over 3 in the front. And then 7 over 3 minus 1 leaves us with 4 over 3. Okay, now we can just simplify further. So therefore, g prime of x is equal to negative 4x to the negative 3 minus 7 over 3 x 4 over 3. And we can leave it in this form. If you'd like to convert it to being fractions and also adding a root sign, that's also fine. Okay, moving on to 8.2. We've been asked to determine the equation of the tangent to our function at the point where x is equal to 2. So the relationship between curves and tangents is that they have the same gradient. And we can get the gradient of a curve by taking the first derivative at that specific point. So let us do that. So we're looking at 8.2. Our function is equal to x cubed minus 4x squared plus 2x plus 3. And taking the first derivative, you get 3x squared minus 8x. And here it's just plus 2 and the 3 falls away because it's a constant. And we need to calculate the equation of the tangent. So that means we need the gradient. And we said the gradient of your tangent will be equal to your derivative at that point. So we substitute 2 in place of x. Now the derivative when we substitute 2 becomes 3 2 squared minus 8 2 plus 2. And This therefore simplifies to just being 3, well, let me write it here. M is equal to, then this is 3 times 4 is 12, and minus 8 is minus 16 plus 2, which is equal to negative 2. So that's our gradient. Now we need to get the y value at x is equal to 2 so that we can get the equation of our tangent. And a tangent is a straight line with the equation y is equals to mx plus c. And in order for us to get the c, we need the y value. So let's get the y value when x is equal to 2. So y is equals to the function when x is equal to 2 cubed minus 4, 2 squared plus 2 plus 3. And this gives you an answer of negative 1. Okay, so therefore we've got our point, which is x is 2 and y is negative 1. Nice. Now we've got m and we've got our point. We can substitute it into the equation of the straight line and get the equation of our tangent. So the equation of a straight line is, we can get it using this equation, y minus y1 is equals to m x minus x1. Okay, for y1, we substitute the y value we got. Substitute our gradient, which is negative 2, and here for x1 we put 2. Okay, now we can just simplify. This is y plus 1, and here we've got negative 2x plus 4. And then taking the 1 to the other side, we therefore end up with negative 2x, 4 minus 1 becomes plus 3. And this is therefore the equation of our tangent. So equation of tangent. And we have solved the problem. Okay, great. Let us now move on to 8.3. We've been given a function which is equal to negative 6x squared. Then in 8.3.1, they ask us to determine the first derivative from first principles. Okay, so 8.3.1. Our function is negative 6x squared. Now you should always start by writing the first derivative in terms of first principles. So that's f prime of x is equals to the limit as h is approaching 0 of fx plus h minus f of x all over h. So we already have the equation of f of x. Let's get the equation of fx plus h. So wherever there's an x, we're going to replace it with x plus h. And then we close our bracket and then we square it. So this then becomes, simplifying it, negative 6x squared plus 2xh plus h squared. Close our bracket and then we multiply the 6 inside, which is negative 6x squared, negative 12xh plus, also minus 6h squared. Okay, now that we have this equation, it's too thin, let's make it a bit thicker. Now that we have this equation, we can substitute it back into our first principles formula. So therefore, f prime of x will be equals to the limit as h is approaching 0 of negative 6x squared minus 12xh minus 6h squared minus, I'm going to put a bracket around our function of f of x, that's negative 6x squared. And then in the denominator, we have h. So how you know if you are on the right track, you should have that your original function over here will be subtracted once you've substituted everything. And we can see that it's going to be subtracted over there. So f prime of x is equals to the limit as h is approaching 0, and minus 6x squared plus 6x squared add up to 0, so we know we're on the right track. Now we're just left with 12xh minus 6h squared divided by h. And now we can see that we can factor out an h, and that will allow us to get rid of that denominator. So f prime of x is equal to the limit as h is approaching 0. We factor out h, then we've got negative 12x minus 6h. And in the denominator, we have h. Now, these h's cancel by each other. So, thus we are left with limit as h is approaching 0. And here we just have negative 12x minus 6h. Now we've reached a point where we can no longer simplify anything further, meaning that we can now get rid of this h because the limit of h is approaching 0, meaning that if we were to substitute 0 there, we would end up with 0 for this term. This term goes to 0. Therefore, our first derivative is equal to, because we are assuming that if we substitute h, that term goes to 0, so we no longer write the limit. So now we're just left with negative 12x. And that is therefore our final answer. Nice. Let's move on to 8.3.2. Write down how you will restrict the domain of f such that the inverse of f is a function. Okay, so our original function is negative 6x squared, which is a parabola. So our parabola probably looks like this. If that's the equation, this is negative, meaning that we've got a negative parabola. So it's got this shape and it's at the origin. So it looks like this. That's how this looks. So for us to then get an inverse, if I draw the y is equal to x line, y is equals to x line, it means that the function will look, if we reflect it on this line, this part is going to come, let's see, this part is going to come like that, and then this side is going to look like that. So this is how the inverse is going to look like. So for us to restrict the domain so that this inverse remains a function, it either means we need to pick one side. So it's either we're going to keep the top part or we're going to keep the bottom part over here. But we can't keep both sides of the inverse because the inverse will no longer be a function. It needs to be restricted. So that means for us to keep one part, we need to restrict the original function. And what that means for the original function is that we either keep this side, so let me highlight. We're either going to keep this side or we keep the other side. Meaning it's either x has to be equal to or greater than 0 or x has to be equal to or less than 0 for us to have our inverse being a function. So to finally answer the question, we are therefore going to restrict it such that x is equal to or greater than 0 or x is equal to or less than 0. Okay, let's move on to 8.3.3. Determine the equation of the inverse of f where the y values of the inverse are negative, and write your answer in the form y is equal to. Okay, so let's first start by getting the inverse before we then write the final equation. But already we can see based on our little sketch I drew over here, we want the one where the y values of the inverse are negative, meaning that we are picking the pink highlighted side. Okay, and the pink highlighted side matches the blue highlighted side of the original function of f. Okay, so and that original part of the function where it's blue, that is the part where x is equal to or less than 0. But let's get the inverse first. So we start with the equation of y is equals to negative 6x squared. We swap our x and y's, so we now have negative 6y squared. And now we want to solve for y. So divide both sides by negative 6. This cancels. Now we are left with y squared is equal to x over negative 6. And then we're going to square root both sides. And this will allow us to just have y by itself. Y is equals to the square root of x over negative 6. And this square root will either be positive or negative. And we were instructed that we want the negative part of the inverse, which we identified to be the pink highlighted section. And that section matches the blue part. So therefore, the equation that we want that will allow us to have negative values will be y is equal to negative square root of negative 1 over 6x. Okay, and we have to restrict the domain of the original function. We already wrote it at the top, but we can write it here again. And we said that is for when x is equal to or less than 0. And that is our final answer for 8.3.3.